morning, good afternoon, good evening, EL 115 students. This is your Hillbilly instructor, Scott Sexton. So this is week 3, part 1 uh, lecture on understanding conduit field calculations. The first part of this, we're going to show you what to look for, and we're going to work one question. In the next video, we'll be continuing to work these questions. That way you can understand them. So let's get started. First thing you want to do is you be able to understand the steps that it is to complete a conduit work question. Okay, you need to ask and understand what the question is asking for. In order to do that, you need to look for keywords. Keywords will be able to indicate where to go, and that's a standard thing for doing any kind of our electrical testing. You always want to look for keywords in a question. As a side note, being able to do this conduit calculation is a requirement in any of my classes that you take, and it's a requirement for you to be able to do this out in the field. You never know when you're going to get to a job that does not have engineering on it, and they tell you, hey man, I need to get this over here, give me a 30 amp circuit over here, give me a 50 amp circuit over here, and put it in EMT or put it in the rigid. And you have to go back as an electrician, you got to go back, all right, 30 amp circuit, what size of wire for a 30 amp circuit, what's our conditions, what size of conduit, how many wires. So you have to do that as an electrician. So first thing you do is look at the keywords. Make a note of the conduit type and the notation of the length. It's going to be critical information at the end of this. We've already talked about it. If not, there's a difference between how many wires you can put in or the percentage of fill you can put in for a conduit based on the length of the conduit. Keep in mind, as a quick reference, anything less than 24 inches, okay, that's the inches sign, you can fill it to 60% of its fill. All right, quick, just keep that in mind. So now what are we doing here? We're going to keep working through and looking at what the process steps are to do this. So look for variations of the conductor insulation, i.e. if it's a THHN and they're all THHN, fine. But if you have THHN, which is the insulation, and you have an RFH, that means you've got two different thicknesses and you're going to have to go, you have two different volume sizes. That means you're going to have to look at the chart a couple different times. Make a note of the inches square for each of the different conductor types. That's what we're referencing up here. Look for odd wording in the question. What size of conductor? Well, if it's telling you what size of conductor, there should be a reference for ampacity. And then when you see that, you're going to automatically think about 31016. So we've looked at the question, we've analyzed it. Okay, now what do we do? Well, we're going to take the information. So when to give a conductor count and insulation, you will use with the given width, given count, and the insulation. You use the following NEC tables to complete the calculation. Okay, you'll go to T5 first. That's where you get your inches squared. Okay, then you'll go to T4 to find the final conduit, whether it be an EMT, an ENT, a rigid, or whatnot. And this, I have some examples over here. We'll do a real quick look at it. And when you have to use that to be able to conductor size, and again, that's working off of ampacity. All right. So, give you your examples right quick. Our example A, meaning we're going to table 5 to find the right insulation approximate area. Well, that means we're looking over here. Table 5, dimensions of insulated conductors and fixture wires. We go and find our wire type, which is right in here on the left, and we come across, and that tells us a wire size. Well, if we don't have a wire size, or if we do have a wire size, we need to get an inches square on it. Well, that means that your volume taken up. So, for example, an RHH, number 12, requires 0.0353 area of volume in a conduit. So, say, for example, we had one of these or 5 of these, however you want to do it. I would multiply this times 5 and come back and get my proper trade size. So here's a quick one we can do right off the bat. A quick insulation or installation. So let's say just for sake's sake, we have 5 of these. And I want to find out what size of conduit I've got to put in it, or I've got to put these in. What do? I come over here in my handy dandy calculator and I do 5 of the wires times this number right here, which is 0.0353. That equals that number. That number is 0.1765. All right, they're numbers. We don't really care about them. Well, the numbers are going to transfer down here. Uh, did it say anything in our question? Did we mention anything about the conduit length? No. So we're going to make the assumption that it is not a 24-inch or less conduit. That means we have to go in and use the over 2 wires. Standard for most calculations. So I have 1765. Where does that fit?
Uneducated man.
Well, my smallest conduit half-inch is a volume area over 2 wires of 122. Well, that's less than this guy. So now, what's the next one? 3/4, right here. This guy right here, that's 0213, which is bigger than 0.176. So the answer to this particular question, having 5 of these number 12s, I can get it into a 3/4 conduit. It's that easy. You can review back what we talked about, okay? But these are some examples that we can use. And I have a couple of questions that we're going to roll through. This week, you're going to find questions from me about conduit fill. We're going to use not only these particular tables, but we're also going to be playing with the ampacity of the conductors, and you have to use multiple tables on 31016, 31017, and 31018, depending on the installation. Now remember, when you're having to do ampacities at all, it has a direct reflection on what it is your ampacities. If it's 31016 is all based on conductors that are in raceway, cable, or direct buried in the earth. When you start getting something that's on a messenger wire or open air, well, there are different tables that you use, and you actually get more ampacity out of the wire whenever you do that. So now let's look back over here and start looking at what our questions are. So let's work this first question. For this particular exercise, we're strictly going to be using the 75-degree chart to be able to make it easy. We're not going to also do any D-rating for multiple conductors in the conduit. We're just looking about what size of wire. We're going to assume somebody else has done that. So what do we have? A client requested the conduit be ran to connect a piece of equipment to his existing service panel. In the conduit, it's required to have 4 number 12 THWN and 8 XHHW. And the size, that question is, what size ENT will the client need? All right, well, first thing we do, we look at keywords. I'm looking at ENT. I'm looking at number 10 XHHW and number 12 THWN. So the first thing I'm going to do is I'm going to write me some notes down. First note is it's ENT. That's going to be my conduit type. So I'm going to go over and I'm going to find ENT in my on my tables, chapter 9, table 4, and I'm going to bookmark it. Next thing it is talking about my XHHW right here, and they're number 10s. So I'm going to write that down. And I'm going to put on there that I have 8 of these. What does that mean? That means I'm going to have 8 times whatever the inches squared of this conductor is. And that's going to be the same thing when we get down here. What are we looking at? We have 4 of the THWN. So I'm going to write THWN. And then I have, what size is it? It's a number 12. And then I have 4 of those. And it's going to be 4 again times the inches squared. So what do we need? So I need to know what this value is right here. Okay, so let's get our code books out. And we're going to go flip over to chapter 9, table 5. And in here, mine is listed as this. And what are we doing? We're looking for THWN conductors. All right, so I'm going to scroll down through here until I find my THWN. Again, we're looking on the left-hand side. THWN. He's not here. Where's he at? Oh, there's my THWN. So right there in your code book, I'll expand mine out. It put me all the way back to the top. Let's get back down here to it. THWN. THWN. And then I had number 12 size conductors, right? That number right there is 0.0133. And for this, for example, we're going to do 0.0133. And we're going to get this guy out of here. Let's get back in. Put that in there for what we need. At number 12, what was it? THWN 0.0133. Well, we can go ahead and finish that calculation out right now. It's right here in front of us. I'm going to multiply that number right here times 4. That number, that's how many we have. It says 4 the number 12s. It's going to be equal to this number, which is 0.0532. All right, now what are we going to do? Well, we're going to go back to that same chart, Chapter 9, Table 5, and see if we can find the XHHW conductor. So we're going to have 8 times whatever that is. See if we can get back to it. That was what? Was it XHHW? It was XHHW. Let's go down through here until we find XHHW. Oh, looky there. And the XHHW, if I'm not mistaken, here's XHHW, and we're looking for number 10. So that's going to be that third column over here. Number 10 is 0243. So I'm going to write that down, 0.0243. I'm going to go validate that we are looking for the right wire. I think it's a number 10. Whoop, there's the number 10. So we got that right. That's that value for number 10, and we have 8 of those. So we're going to multiply this times 8, and we'll write that number down. 0.1944. Let me expand this out. I didn't write that last part down. We'll get that in here. 0233, was that what that was? Let me get that pulled back up for us. 0243. Make sure we get our numbers right, because you know when you get off one little digit, it actually could cause you problems. So it's 0243. Eight times 0243 gives you that total right there. All right, now what are we doing? Now we just add these guys up. Okay. Here's the handy dandy calculator again. Put him right over here so you can't see me. Oh, you probably can see over. So now we're going to add these guys up. 0.1944 plus 0.0532 equals. So write that down so we don't lose it. Have a total of 0.2476. Okay, and you guys, if I've made a mistake in my math, you good math majors, double check me. I'm just an old hillbilly. So now, what have we done? We've got our total volume of wire that we need to put into this ENT. So what are we doing? Now we're going to go back to what? Chapter 9, Table 4, and find a number that will fit this. And we're going to leave this guy up here as a placeholder for my eyes, because I can't see real well. So we're going to get rid of this guy, and we're going to go back, and what are we looking for? I'm looking for ENT. Well, that just happens to be right here. We can see this right now that I'm looking for over 2 wires because it didn't say anything about it being less than 24 inches. I'm going to come down through here and I'm going to find a number that is equal to or greater than this number. Well, that half inch ain't going to work because it's only got that number. This number for 3/4 is 0.203. That's actually less than what this number is here. So that means we're going to go in with a 1 inch with a total volume of 0.333. So 1 inch, the answer to this question for an ENT is 1 inch ENT. And just for your notes, just in case, write down what that total volume was for that guy so you can actually see it. Okay? That way you can see what your total volume is on it, and that way you kind of know. But that would be the answer for this guy is 1 inch.
Electricity.
So that is our walkthrough for the first question. Okay? The next video or the next lecture will be the walkthrough for 2 and 3. I don't want to keep these things any longer than what they need to be because I know you guys are just already lost track on me now and probably had already jumped through the video. If you haven't jumped through the video, kudos.
Awesome. Awesome.
If you have, I can see it. I really hope you get these calculations right because I'm going to do a walkthrough like this and then I'm going to expect you to be able to understand it and reference this video. Again, we use this all the time as electricians. Be looking for my video later in the week and be looking for posted questions for you guys to be able to take care of to get practice doing this. And again, thank you for your time. Thank you for being Dorsey. And if there's any problems, if you have any questions, reach out to me. I'm here. Some of you already do and have, and I appreciate it. There will be a discussion question this week that'll be group discussion, and everyone is expected to participate. Otherwise, your grades will reflect your lack of participation. Thank you very much, and have a wonderful day.